Have you ever looked up at the night sky, seen a bright streak of light moving across the stars? Sometimes that's a rocket heading into space. One of the most famous rockets flying today is the Falcon 9. It is built by a company called SpaceX. SpaceX was started by Elon Musk with a huge goal: to make it possible for people to live on other planets, like Mars. To do that, we need really good ways to get to space. To do that, we need really reliable ways to get to space. To do that, we need really affordable ways to get to space. The Falcon 9 rocket is a very important step toward making that dream a reality. It has flown hundreds of times, carrying supplies for astronauts, satellites that give us internet, satellites that give us GPS. The Falcon 9 is a two-stage rocket. Think of it like a big pencil with a smaller pencil on top. When you think of rocket launches in the United States, you might picture Florida's famous Space Coast. But SpaceX also launches from another very important place, Vandenberg Space Force Base in California. Yesterday's beautiful launch lifted off from this West Coast site. The reason for launching from different locations has everything to do with where the rocket needs to go in space. It's all about direction and safety. Launching from California allows rockets to fly south over the Pacific Ocean. This path is perfect for putting satellites into a special kind of orbit called a polar orbit. A polar orbit means the satellite travels over the Earth's north and south poles. As the Earth spins beneath it, the satellite can eventually see and scan every single part of the planet. Satellites that take pictures of Earth monitor weather patterns, track climate change, or perform spy missions for national security often need this kind of pole-to-pole coverage. By launching south from Vandenberg, the rocket and any falling parts avoid flying over populated areas, making the ocean a safe drop zone. Vandenberg has a long and storied history with space. It has been a key launch site for the United States for decades. The base is huge, giving rockets plenty of open space for their fiery ascents. For companies like SpaceX, having access to Vandenberg is essential. The moments before a rocket launch are filled with incredible tension and excitement. In the final minute, the command LD is go for launch confirms that the launch director is ready. Then a computer takes over the final countdown sequence. With 10 seconds to go, a powerful system starts flooding the launch pad with thousands of gallons of water. This isn't to put out a fire, but to absorb the intense sound waves from the engines, which are so powerful they could actually damage the rocket itself. At T-3 seconds, the command is sent to ignite the 9 Merlin engines on the first stage. They roar to life in a carefully timed sequence. When the countdown hits 0, we have liftoff. The giant clamps release, and the rocket begins its slow, majestic climb. At first it seems to move in slow motion, but it quickly picks up speed. Within a minute, the rocket is traveling faster than the speed of sound, an event known as Max Q, or maximum dynamic pressure. This is the point where the combination of speed and air density puts the most physical stress on the vehicle. The 9 Merlin engines continue to burn for about 2.5 minutes. They consume a massive amount of super-chilled rocket-grade kerosene and liquid oxygen. This powerful burn pushes the rocket to an altitude of about 50 miles and gives it a speed of thousands of miles per hour. The view from the ground during this phase is breathtaking, especially for launches at dawn or dusk like yesterday's. Once the first stage has used up most of its fuel, its job is done. At about 2.5 minutes into the flight, main engine cutoff, or MECO, occurs. The 9 Merlin engines shut down. The rocket coasts in silence. A few seconds later, pneumatic pushers activate and stage separation occurs. The second stage now ignites its single Merlin vacuum engine. Meanwhile, the first stage starts its return. This is reusability in action. The booster flips around using small gas thrusters and performs a boost back burn toward shore or a drone ship. A re-entry burn slows it, and a final landing burn brings it to a gentle touchdown on landing legs. Meanwhile, the second stage fires for about 6 minutes to reach a temporary parking orbit. After engine cutoff, SECO, the vehicle will coast for a while. The timing of this coast depends on the mission's target orbit. The protective nose cone, or fairing, is jettisoned during this phase. Fairing halves fall away and are recovered at sea. Finally, satellite deployment begins. For Starlink, 50-plus satellites are released at once from a special dispenser. The single most important thing that makes the Falcon 9 rocket special is reusability. For most of space history, rockets were like airplanes that you could only fly once. Imagine flying from New York to Los Angeles and then throwing the entire plane away. It would be incredibly expensive. They would burn up or crash, making spaceflight extremely costly. SpaceX, with the Falcon 9, completely changed this way of thinking. The Falcon 9's first stage booster is designed to fly back to Earth and land itself upright. It can land back on a concrete pad or on a robotic drone ship floating in the ocean. After landing, the booster is inspected, refurbished, and prepared to fly again. Some of these boosters have flown more than 20 times. Reusing the most expensive part drastically cuts launch costs. It's the key innovation that has allowed SpaceX to launch so frequently. Another special feature is how SpaceX builds almost everything itself. Vertical integration at its Hawthorne factory. That gives them control over design, quality, and cost, and lets them apply lessons from one launch to the next. Ultimately, the Falcon 9 transformed the entire space industry, sparking a new space race focused on sustainability and cost-effectiveness. Every launch, like the beautiful one from Vandenberg yesterday, is a demonstration that rockets don't have to be disposable, bringing ambitious projects like global internet and dreams of Mars closer than ever.